Okay, so as promised, I wanted to just kind of share with you some rules on how to create something called Lewis dot structures. And the reason that I've decided to start incorporating this into our class is this gives us a great visual concept of how molecules behave and maybe why they behave the way that they do. And again, it's just kind of fun to follow some rules and, of course, just play around with some molecules and building. And I'll share with you a website that will allow you to see the molecules three-dimensionally, and you can manipulate them. And it's just really, really cool. And it kind of gives us a new respect or a new regard for electrons. Okay, so Lewis dot structures and the octet rules. Remember that octet means 8. And so every atom, with the exception of hydrogen and helium, want to follow something called the octet rule. Now, boron is also going to be an exception. We're going to talk about him a little bit later. But for the most part, everybody wants to follow the octet rule. So the Lewis dot structures are structural representations of molecules. They give us ideas of connections between atoms. And remember, the connections are going to be the sharing or the giving and taking of electrons, because we talked about ionic and covalent compounds. Okay, so if you look at the two molecules that are on the board, we can see carbon tetrafluoride, fluoride, and we also see the water molecule. And I've given you some different pictures, but this is the one that we are going to mostly work with. I think this is the easiest one for you to see. So these electrons right here, there are 2 pair of electrons. And so each one of these lines represents 2 electrons, okay? So if you remember from the Bohr model that you guys did, oh my goodness, way back when we were drawing those, we tried to keep those models, the electrons within those models paired up. Number one, it makes counting easier, and it looks really pretty, but it's kind of being mimicked here with Lewis structures. Okay, so that's just the basic stuff. These electrons here belong to fluorine, and these electrons right here belong to carbon, but he is sharing these 4 electrons here. Now, if you'll notice, carbon, okay, so let me write his name. He is in group 4, so he is a group 4, and that means he has 4 valence electrons. Fluorine has 2, 4, 6, 7, so he is in the 7th group, or group 7, and he has 7 valence electrons. Now let's take that back to the octet rule. If carbon is in group 4, he needs 4 valence electrons. He needs to share 4 electrons, and that would give him his 8. And then for fluorine, he only needs 1 more electron, so he's going to share an electron with carbon and therefore get his 8. So that's the name of the game, is developing 8. So Lewis structure rules, we're only going to show something called valence electrons, not those inner shell electrons. Stable compounds want to achieve a stable configuration. They want that full shell, and so they must obey something called the octet rule. I don't know if you can see that. Let me write this in. So the octet rule, and that's 8 valence electrons, and of course Y. And if you look at group 8, and so that's referencing those noble gases. Okay, so referencing those noble gases. Now hydrogen follows something called the duet rule, and that would be hydrogen and helium because they only have 2 valence electrons. So they don't have room to accept other electrons because they only have that one s orbital, and you can only put 2 electrons in those. So here's how this works in a nutshell. First of all, we need to sum up all the valence electrons in the atoms, and we're use pairs of electrons to form single bonds. Okay, so I am going to insert a page. Hold on just a minute. Let me insert a page here. Okay, I'm going to move you down just a little bit. Insert a page after current. Oh, it's going to be really bright, so sorry. And we're going to do this in black. because black is always fun. I'm going to write in yellow because I love black and yellow. Because the contrast is fantastic. So so he said we got to sum up the valence electrons. Okay, so let's sum those up. And only the valence electrons. And so for the valence electrons, you would do their group number. Okay, so the one that we're going to look at together, so let's keep this very simple. We're going to look at methane, which is CH4. Okay, so carbon has 4 electrons. Okay, and then hydrogen has 1 because he's in group 1, but there are 4 hydrogens. So I'm going to say 4 times 1. So that gives me 4 plus 4, and that is 8 valence electrons. Okay? Now I'm going to scroll back to the previous page because this has got our rules on it. And let me roll that up just a little bit. Okay? And it says use pairs of electrons to form single bonds, and you're going to always kind of start with the central atom. And of course, now we need to kind of figure out who the central atom is. So let's go back to our example. Hydrogen can only form 1 bond, so it wouldn't make sense to put him in the middle. But carbon needs 4 because his valence number is 4, and 4 plus 4 is 8. So let's put carbon in the middle. So carbon's in the middle. And then we're going to put the hydrogens around carbon. Now remember, each one of these lines is going to represent 2 electrons. Okay? And I use the lines because I feel like sometimes the dots can get a little confusing, and I keep the dots reserved for those on the outside, just like we saw with carbon tetrafluoride. Okay, now so we needed 8 valence electrons. We have 2, 4, 6, 8. So this is a great Lewis structure for methane. Okay, now let's go back and look at our rules again. It says arrange remaining electrons to satisfy the octet or duet rule. And so we did that for both hydrogen and carbon. If the octet rule is not satisfied, you can either rearrange bonds and or add in double or triple bonds. Okay, so we did the first example here, so let's do this C2H2. Let's kind of wiggle our way through that one. Okay, so we got C2H2. First things first, I need to sum up the valence electrons. Okay, so carbon is in group 4, and there are 2 carbons, so 2 times 4. Okay, hydrogen is in group 1, there are 2 hydrogens, so 2 times 1. Okay, so 2 times 4 is 8, plus 2 is 10. We have 10 valence electrons. Okay, so much like I did over here with methane, I'm definitely going to put the hydrogens on the outside because they can only form 1 bond. So always put the hydrogens on the outside. They are going to never be in the middle. Okay, so I have carbon and carbon. Now there are 2 of them here. Now in methane there was only the 1. So I'm going to write 2 because there are 2. Okay, and then I'm going to put a hydrogen on either side. And I always think symmetry, so make it pretty. Nature doesn't like investing energy into things that are awkwardly shaped or things that are very cumbersome. So always think symmetry. Okay? So we needed 10 valence electrons, and so far we have 2, 4, 6. So I need to have 4 more electrons. So I'm going to put, and I'm going to use dots this time to separate it. Okay? I'm going to use dots this time. And I look at the structure, and this is 2, 4, 6, 8, 10. And that's exactly what we needed. That's exactly what we needed. But now here's a catch. How many electrons does carbon want? So he always wants to have 4, right? Well, if I look at this, he owns these 2, and he shares these 2. So we've got 2, 3, 4. So does that check out? Of course it does. And it does this for both. So this carbon is sharing that one and is sharing that one. And then, of course, he owns these 2 here. And so we've got 2, 3, 4, 2, 3, 4. Okay, so we've got 4 electrons on both sides. That's wonderful. And then the hydrogen, of course, has the duet rule. So this is pretty easy. I mean, all we got got to do is sum up those valence electrons and make sure everybody is meeting their valence shell and they've got adequate electrons. Make sure you keep hydrogen on the outside. So let's look at one more example. Okay. Let me back up just a little bit, make sure I didn't skip nothing here. Okay, so we've got this. We drew methane and C2H2. Okay. Okay, so now I've got some, let me clean up my board just a little bit here. You can tell that I've been kind of doodling. Okay, so we're going to draw the Lewis structures for the following compounds. And I thought it would be a great opportunity for us to take a commercial break, and you try to draw these, and then I will draw these, and we'll compare notes. Okay? So give it a try.